Hello, and welcome to For Sleepy Scientist. If you're here, you're likely ready to relax and fall asleep, or maybe just calm down after being wonderfully human all day. Either way, you're in the right place. Tonight, we'll go on a slow and peaceful journey through time. Not with science fiction, but with the kind of time that moves quietly in your kitchen, your body, and the world around you. This is the chemistry of time. It's about how molecules slowly change, grow old, ripen, rust, ferment, and break down. It's about slow changes and the hidden beauty of things transforming when no one is watching. I hope this video doesn't keep you awake from being too interesting. But if it does, at least you'll leave with new knowledge to dream about. Maybe you'll even dream about lazy atoms or soft flowers. Stranger dreams have come true. Before we begin, if this mix of science and calm makes you feel better, please tap like and subscribe to the channel. It helps me make more content like this. Also, I'd love to know where in the world you are and what time it is. You can write it in the comments if you like. I think it's beautiful to imagine people everywhere listening to the same peaceful science under the same sky. And just so you know, this video is not medical advice. It's just here to satisfy your curiosity, not to treat anything. Now, let's begin our slow journey through the chemistry of time. Rust. That word makes you think of an old bike left in the rain or a nail turning into red dust. But behind that orange surface is a quiet and steady story of chemistry. An invisible clock that runs through air and water. The main cause of rust is called oxidation. Even though it sounds like something from science fiction, it's happening all around you, maybe even on your tools. Oxidation is when one substance gives electrons to another. With rust, iron gives electrons to oxygen in water. This turns it into iron oxide, which we call rust. Iron alone is strong, but with oxygen and moisture, it gives up its electrons. As electrons go to oxygen, the iron changes and becomes iron oxide. This new form is reddish, flaky, and weak compared to the original. That's why metal things like bridges and ships are checked often. Rust doesn't just look bad. It's decay at the level of atoms. But oxidation is not just about iron. It also includes apples turning brown and wood burning. Fire is fast oxidation. Rust is slow oxidation. It sneaks in over time, quietly shaping metal like an artist using a feather. Rust is both harmful and poetic. Iron, once taken from earth, melted in fire, and made useful, will one day turn back to dust. The universe undoes our work one atom at a time. Even our toughest tools will return to soil. Rust depends on time. It's not instant. It needs air, water, and patience. Moisture speeds it up, dry air slows it down. That's why old iron in dry places can last for thousands of years, while a tool left in rain might rust in a week. Scientists can read rust like a clock. The layers of rust show the age and the environment. On shipwrecks, the rust tells how long the ship was underwater and what kind of water it faced. Even the type of iron oxide, like hematite or magnetite, gives clues about the rust's life. But rust can sometimes help. Certain steels form a tight rust layer that protects the inside. This steel is called weathering steel. It rusts on the outside but stays strong inside. The chemistry of this rust depends on the alloy and the weather. If there's too much water or pollution, rust keeps flaking off. But in perfect conditions, it stops itself. That's why builders use weathering steel. It looks good and tells a story as it ages. Rust can even be beautiful under a microscope. It forms tiny crystal shapes, like flowers or branches. In calm places, the crystals grow nicely. In harsh places, they grow rough. Rust may seem simple, but it's a dance of electrons, water, and oxygen, moving slowly with time. Unlike other reactions that finish quickly, rust takes its time. It grows layer by layer, showing time not in hours but in rust flakes. Rust connects air, water, and earth. Without water, rust barely starts. Without oxygen, electrons don't move. Without iron, none of it happens. They all work together. In our bodies, something similar happens. We face oxidative stress. Our cells lose electrons too, which causes aging. We don't turn to rust, but we do wear down. Rust is like a memory of time passing. It doesn't just show that something is old. It shows how nature took over. The more rust, the longer the story. Rust touches everything, from tools to ships, from swords to gates. It may take years, but it always arrives. Rust teaches us that change is natural and sometimes beautiful. So when you see a rusty thing, think of the chemistry, not just the decay. It's a transformation, a sign that iron met air and slowly chose to change. Rot may not sound exciting, but it's one of the most important things in nature. Without rot, the world would be full of old leaves, leftover food, and waste. Nature has a system for clearing the old and returning it to the cycle. That system is decomposition, and it's powered by chemistry. Molecules break down, mix, and return to the earth. Rot is the breakdown of life, run by chemistry and microbes. While rust changes metal, rot works on plants, animals, fungi, and even us. It starts when life ends. The body's systems stop. Barriers break, and microbes see a chance. Microbes are the cleanup crew of Earth. They don't wear uniforms, but they work hard. They use enzymes, which are like tiny scissors that cut proteins, fats, and sugars into small parts. They work fast. Take a banana. As it gets soft and smells sweet, microbes and enzymes are at work. Starches turn to sugar. Proteins break into amino acids. Fats break into fatty acids. These new parts evaporate and make smells. Rot is not random. It follows steps. First, the body's own enzymes digest the cells. Then, the bacteria in the gut take over and release gases like methane and ammonia. These gases make the smell we know. Fungi help too. They break tough parts of plants, like lignin and cellulose. They use strong enzymes that digest the hardest bits. Rot is selective. Not all things rot fast. Watery fruits rot fast because microbes love water and sugar. Dry grains last longer. Temperature matters too. Warmth speeds decay. Cold slows it. That's why we use fridges. Oxygen matters as well. In air, bacteria use oxygen and make carbon dioxide. Without air, in sealed places, bacteria make methane and sulfur smells. That's why rot can be slimy. As things rot, they get soft because the cell walls break. That firm tomato turns into mush. Then comes slime. As bacteria grow, they release sticky stuff that holds water and food. That slime is a sign microbes are very active. Rot may seem gross, but it's needed. It recycles food back into nature. Without it, forests and oceans would be full of trash. Microbes even fight for space during rot. Some release antibiotics to block others. Some wait as spores. Some eat only certain things. They pass the work like a team. In forensics, rot helps tell time. Experts study gases, bugs, and changes to find when death happened. It's exact science. Rot helps many living things. Some animals, bugs, and fungi live off rot. Even humans use rot in compost, food, and cleaning. It's not destruction. It's change. Rot shows us that the end is also a beginning. Molecules don't die. They become something new. A fallen tree becomes soil. Moldy cheese becomes an ecosystem. Rot is a circle, slow, sticky, and alive. Now let's talk about ripening, a kind of transformation that feels nicer than rust or rot. Ripening turns green bananas yellow, hard peaches soft, and sour fruit sweet. It's chemistry with a smile. It doesn't break things down into dust, it brings out the best in them. Ripening happens because of molecules called plant hormones, especially one called ethylene. Ethylene is a gas, and plants release it when it's time to ripen. It's small, but powerful. Just a tiny bit in the air can change everything. That's why one ripe fruit in a bowl can make the others ripen faster. You've probably seen that with bananas. When they start to ripen, they release more ethylene, which makes the others ripen too. This is called a positive feedback loop. The fruit is telling itself, and others, it's time. Inside the fruit, ethylene changes enzymes. These enzymes soften the fruit by breaking down pectin, which is what makes things firm. It also helps change starch into sugar, making the fruit taste sweeter. It also changes color, smell, and even nutrition. That green banana becomes yellow, the astringent taste becomes sweet, the hard bite becomes soft, and the smell becomes fruity. Ripening is like a soft celebration of being ready. But ripening is risky too. If it goes on too long, ripening becomes rotting. Sweet becomes sour, soft becomes mush, smell becomes stink. It's a tight line, a short window. That's why farmers and markets work hard to control ripening. They slow it down with cool air and low oxygen. They speed it up with ethylene sprays. Timing is everything. Not just for fruit, but for chemistry too. In our lives, we ripen in other ways. Not with ethylene, but with time, choices, and experiences. We become sweeter, softer, more ready. Ripening reminds us that change can be beautiful, and that softness is not weakness. It's timing, it's maturity. In science, time is not just something we track on clocks. It's a force that moves atoms, changes matter, and shapes everything. Chemistry is time in action. A cup of tea cools because heat spreads. A candle melts and burns because molecules break and reform. Bread rises because yeast releases gas over time. Even the smell of rain is about time. Oils in the soil wait dry for months. When rain hits, it releases a molecule called geosmin, which we smell. That smell is not instant. It's built slowly, released fast, remembered forever. Time moves through us too. Our cells age, our hair grows, our memories form. Even our thoughts have chemistry. Neurotransmitters like dopamine and serotonin flow and fade. They spike in joy, slow in sadness. They are chemistry shaped by time. Even sleep has a rhythm, a chemical pattern. Melatonin rises in the evening, telling the body it's time to rest. When morning comes, cortisol rises, waking us up. These are natural clocks ticking in every cell. Chemistry and time are partners. One can't move without the other. A chemical reaction is not just what changes, but when. Fast reactions boom like fireworks. Slow ones build like rust. Some take seconds, others take years. Diamonds form over millions of years under pressure. Wine ages for decades in barrels. Cheese matures in caves. These are slow reactions, but they create richness. Time adds depth to flavor, wisdom to science, peace to sleep. So when you lie in bed tonight, think of the chemistry around you. Your breath carries oxygen that may once have rusted a sword. The sugars in your blood came from ripened fruit. The warmth on your skin is energy from the sun, caught by leaves, turned into food, passed through time. You are full of chemistry. You are made of atoms that remember stars. You are not still. You are always changing. You are not alone. You are part of a cycle. Chemistry doesn't stop when the day ends. It slows, shifts, softens. Just like you. So close your eyes, and let time do its work. Let chemistry carry you gently into dreams. The sleepy scientist will be here again, when you need a calm voice to remind you how beautiful science, time, and sleep can be. Thank you for being here. Good night.